Welcome back everyone to this discussion. This is Namakando Academy YouTube channel. On this channel we post videos for mathematics and physics, particularly for students doing A-levels. Alright, so with me here I have a topic, mathematical induction. This is in mathematics. So please, if you didn't understand this topic in class, this is the place to understand this. Okay, if you have any question, please feel free to leave a comment and we'll surely attend to you. And also, we'll drop our email address in the description box. All right, so mathematical induction. What is mathematical induction? All right, so I want to induct you in the world of mathematics. So mathematical induction is simply a technique. Mathematical induction is a technique in mathematics used to check the correctness of formulae, or rather formulas, mathematical statements, or theorems. We can still substitute or with and. So this is what we have. Or sometimes what can happen is that you'll be given a statement, then you'll be taught to prove. And where mathematical induction is concerned, they'll always tell you to say this is mathematical induction being used. So you only use it in a case where you're taught to do so, unless if it's real analysis you're looking at. Alright, so mathematical induction is simply a technique in mathematics which we use to simply check the correctness of mathematical statements, formulas, or rather theorems. So to check the correctness using mathematical induction, there are steps which you are supposed to follow. Let's break them down. Step one, you'll be given a statement, and in this statement there will be a value n, and in most cases this n belongs to a set of natural numbers, or rather positive integers. So for step one, in a case where you're given such a statement, you test whatever n is, test for n is equals to 1. So meaning that you get your n, which is known as a natural number in most cases, substitute with a 1 and see if that will hold for the given statement. If it does, then you proceed to the second case, which is step 2. So step 2, based on our findings in step 1, here it's an assumption we have. So the assumption is that n is also correct for, the mathematical statement is also correct for n is equals to k if this is true. So if this is true, it also means that n will also be equals to k. This is an assumption. All right. Then after you've made an assumption that n is equals to k, you then proceed to the third case. Under the third case, you test for n is equals to k plus 1. Now the thing is, if you are on the first case and you find out that it's not giving the results which you need, mean that it is not true, then you are not allowed to proceed to the other cases. You end here and conclude to say the given mathematical statement is not true by mathematical induction. Then if it is true, then you proceed with these cases. So here, after step 3, we then have conclusion. So for this part, you conclude either the given statement is true or it is not true. Alright, so this is how simple this topic is. Please make sure you watch this video up to the end, and after this one, we're going to have another video just be dedicated to us solving questions under mathematical induction. Thank you very much and see you in the next video.